So just to give you kind of a brief context, it's an opinion article by this author, Vincent Cheng, LLMs Are Making Me Dumber. And essentially, it's the stuff that we talk about a lot here, which is that LLMs can't actually produce the kind of code quality that a lot of people think that they can. And there is a non-zero amount of people, let's put it that way, who have leaned on LLM code outputs for a long period of time or even a short period of time. And once they have to step away from it, they realize that they can no longer work at the same capacity within generating code and solving problems that they used to pre-code LLM usage. So this is what he's talking about here. And this was, I thought, a kind of a good series of rebuttals to some of the arguments that I've heard about AI. For example, calculators, GPS, printing press, industrial evolution, chess, assembly to C to Python. So this is really the core of the article that I want to talk about. And since I'm trying to get through this in a timely fashion, I'm going to just focus on these, and we can kind of have I'll see what chat's up to. Let me actually just, it's really hard for me to see chat like this. So yeah, you guys are just going to have to talk, and you're just going to have to accept the fact that I'm going to focus on this and then catch up with chat as best as I can after. Okay. But I appreciate the engagement either way. Okay. So the historical analogies. Calculators. People used to calculate logarithms by hand, and entire careers would be spent doing calculations that can be done in less than 1 millisecond on a modern calculator. No one lamented the advent of calculators. It's a perfect example of offloading menial work, allowing humans to spend more time on the meaningful problems. I'll just zoom in a bit. One distinguishing factor about the situation is that everyone still needs to learn arithmetic. So this is one thing that I have had thrown back at me against AI, which is, well, what about calculators? This is the same thing that people said against calculators, and now calculators are ubiquitous. But exactly this. It does not negate your need to learn even basic arithmetic. We don't say don't learn arithmetic. Calculators can do that already. Just go do algebra. Even though many influential people in AI do say you shouldn't learn coding in the usual sense. You need arithmetic to do everything after. This analogy argues for write 100,000 lines of code yourself before you start extensively using LLMs. While calculators have automated away long calculations, we can still perform these calculations by hand if we needed to. However, I wouldn't be able to write those lines of JavaScript manually. It's a different level of abstraction. And this is really the key differentiation point. This is the threshold breaker of this argument. Can you do mathematical operations by hand should the entire electronic infrastructure go down, never to exist again? And a lot of us could do even basic math by hand. We could operate in that world. But of course, the analogy does not equate one-to-one. As soon as you enter the digital world and say, could you write all of this JavaScript by hand if you were doing it only through LLMs? Would you even be able to come up with the logical operations required to execute code, yada yada yada, etc., etc.? This is not a one-to-one equation. It's a false equivalency or equivocation, let's say. GPS. It's so reliable that I'm fine being unable to navigate. I've never gotten in a situation where I wish I had learned to navigate without Google Maps beforehand. That's kind of the argument. But this is also a narrow skill that isn't foundational to higher order ones. Maybe software engineering will be something as obsolete as navigating, where you can wholly offload it. However, that seems unlikely given the difference in complexity of the two tasks. I actually think this is kind of a weak argument, although it is an argument. I have gone over several studies which are now live on my YouTube, one of them being the fact that GPS usage necessarily forces a decline in your ability to navigate without GPS. It's mental atrophy. That, I think, is a better argument. The printing press, typing. People thought that when computers and typing became popularized, people would stop writing and it would deteriorate their thinking ability. People used to copy and scribe everything by hand to ingrain it in memory, and yes, that might be better than retention compared to typing, but the sheer speed typing provides overrides that. So that's the argument, right? I just don't see how that's actually an equivalent case here, because this isn't the same kind of writing here. Industrial Revolution. A significant portion of menial labor was no longer needed from humans, but the skills here are not the same. The skills that were automated in the Industrial Evolution were not foundational to other disciplines that could be boxed up neatly. The issue is that the skills being threatened are significantly larger in this AI situation. It's intelligence. What's next? Labor, intelligence, and then what? Chess. In 1996, a computer system, Deep Blue, beat Kasparov, the world chess champion, for the first time in history. By 2005, chess engines were better off without any human intervention. 7 years, 1998 to 2005, was the short-lived period when human plus engine Centaur chess was better than engine. Human plus AI will not always be better than AI itself. However, chess is a closed, fully contained system, unlike programming and problem solving, which are more open-ended. I'm actually not sure about that. I'm actually not sure about this argument. If you have a problem and you have programs to execute whatever operations on that problem, maybe solve it, I would consider that to kind of be a closed system, personally. So I've been thinking about this one for a few days, because I read this a few days ago, and I'm not sure about this particular argument, although I do think it's like he's tapping into something that it seems correct. Assembly to C to Python. Almost no one writes assembly by hand anymore unless you work at DeepSeek or FFmpeg, and this is good. Our output increases drastically because compilers do all low-level work for us. While computer science undergrads are still required to take classes on assembly, most productive software engineers never interact with assembly. Moving up the ladder of abstraction has consistently been good. Now, this particular argument I find to be completely false entirely. At the very least, you should know what assembly is. That should be your bare minimum. The reason being that assembly actually does still have a use case for performance even to this day. Do you need to know how to write it or generate it by hand? No, you probably don't. In probably most cases you don't. But should you know what it is, why it existed, what are the abstractions around it? Absolutely you should. I think that's a very core fundamental aspect of software engineering in general. Something that I don't think most programmers are taught or even know. Moving up the ladder of abstraction, I don't think actually has consistently been good. I think it's been rarely good, not consistently good. Because the reasons for an abstraction typically are not based on sound logical conclusions. They're typically based on solving experiential, feelings-based problems. So I kind of disagree with a lot of the premises on here. And you can point to DeepSeek and you can point to FFmpeg as use cases where the performance of those things absolutely benefited by writing assembly by hand. And to be quite honest, assembly isn't really that bad. It's not that bad to learn. It's just a little bit difficult to parse. That's my personal opinion on it. I think a lot of programmers could actually understand assembly, maybe even write a bit of it. And we should have more programmers who can do that, because then you do understand your abstractions a lot better.